myself Rahul Thakkar from LJ Institutes of Engineering and Technology. So what are mechanical waves and non-mechanical waves? So you all are aware about the types of waves such as mechanical and non-mechanical. The waves which require a material for propagation of the wave, any medium of transportation, so such a waves are known as the mechanical waves, and the waves which do not require the material for the propagation, they are known as the non-mechanical waves. So sound waves are the mechanical waves because they require some medium for the propagation. So in here, what is the medium? The medium is the air, atmosphere around surrounding us is the medium for the propagation. So the sound waves are the mechanical waves, but the light can travel in a vacuum as well. So the light waves is the non-mechanical waves. So in this video we are going to cover the topics such as introduction to the types of waves, classification of sound waves, classification of audible sound. So let us start with the first topic of today's session, that is types of waves. So basically types of waves may be classified as mechanical and non-mechanical, but further they are classified as transverse waves and longitudinal waves depending on type of propagation they produce. Okay, first one was depending on medium. Now this is depending on type of propagation. Okay, so they are classified as transverse waves and longitudinal waves. So let us consider first of all transverse waves. So in transverse wave, the particle of a medium vibrate at a right angle to the direction of propagation. As you can see in the figure, the particle vibrate perpendicular to the direction of propagation. This is the direction of propagation, and the particle's movement is perpendicular to the direction of propagation. So the transverse wave consists of crust and troughs. So there is no pressure variation in this, okay, and they can propagate through solid and surface of liquids, but they cannot propagate through the gases. There is no change in the density of the medium while propagation. Light wave is an example of the transverse wave. Okay. Now next comes the longitudinal waves. So in longitudinal waves, the particle of a medium vibrate parallel to the direction of propagation. As you can see in the figure, the vibration is parallel to the direction of propagation. So longitudinal waves consist of compression and rarefaction. In transverse wave, it was crust and trough. Now over here is compression and rarefaction. Okay, there is a pressure variation throughout the medium. They can be propagated through solid, liquid, and gases as well. Okay, there is a change in density throughout the medium, and sound wave is an example of longitudinal waves. Now, next comes the classification of sound waves. So, as we know that sound waves are of three types: infrasonic, audible, and ultrasound. These three are categorized depending on the frequency. The infrasonic sound is a sound which has a frequency less than 20 Hz. Audible sound. Audible sound is a sound which can give the sensation to the human ear. This is only the sound which a human ear are capable of hearing. So audible sound has a frequency ranging from 20 Hz to 20 kHz, or say 20,000 Hz. And whereas the ultrasound has a frequency of about greater than 20 kHz. So the sound which has a frequency greater than 20 kHz is the ultrasound. Okay. Now next topic is classification of audible sound. So audible sound can be understood as a musical sound and noise. The musical sound is a sound which creates a pleasing effect on the human ear, is the musical sound. Whereas the noise, it produces a jarring effect on the human ear. Okay, so the audible sound can be classified in two forms, that is musical sound, that is a pleasing sound, and another one is a noise, that is a jarring sound. Okay, So let us understand the difference between these two, musical sound and the noise. So as we know that musical sound that produces a pleasing effect on the human ear, noise produces a jarring effect on the human ear. That is the first difference. Now the second difference is the waveforms are regular in shape. For the musical sound, the waveforms are regular in shape, whereas for the noise, waveforms are irregular in shape. Musical sound have definite periodicity, whereas in case of noise, it does not have definite periodicity. Musical sound do not undergo a sudden change in amplitude, whereas noise undergoes a sudden change in amplitude. So, as you can see in the figure, there is a waveform of musical sound and the noise at the end. So musical sound has all the properties which are listed above, and the noise shows all the properties as discussed above. So now next topic is simple harmonic motion. So we define simple harmonic motion as the motion in which the acceleration of the body or the force on the body is directly proportional to displacement from a fixed point and is always directed towards the fixed point. That is simple harmonic motion. Simple harmonic motion possesses the following characteristics. First one is the motion is periodic. Another one is when displaced from the fixed point or the mean position, a restoring force acts on the particle tends to bring it to the mean position. Whenever it is offsetted, a restoring force is created inside that and it tends to bring the particle back to its mean position. Okay. Third one is the restoring force on the particle is directly proportional to the displacement. Whatever amount of displacement is made on that, depending on that, the restoring force will be generated. So that's it for today, guys. Thanks for watching.